Hello everyone. This time I want to review the calculus problem. This is an optional problem and problem type is odd type, and the admission year of this KSAT test is 2024. KSAT means Korean Scholastic Aptitude Test, and its number is 28. On this function, we're gonna deal with the negative function, and each um, each specific function is known for the negative values, and the relationship between the in the negative domain and positive domain is given by the two functions gt and ht, such that 2 times gt plus ht equals t. K is constant, and we're gonna find the value of uh, f of 9 over f of 8 given the integration from 0 to x of function fx is e to the fourth power minus 1. Why uh, this problem is rather difficult is related to the shape of each function. So consider the shape of a graph, let's just say graph of function y equals f of x. And this is given negative 4 times x times e to the 4 times x squared when x is negative. But um, it is unknown when the domain is non-negative. The second, the relationship between negative domain and non-negative domain is given by the, let's say, the inverse function of this uh, function of f is given by this one. So we're gonna find what's the value of k and what's the meaning of k. So second point is to figure out meaning of k and its value. Combining these two meanings, meaning of k and value of k, will give us full information uh, about this function when the domain is non-negative. Here, I'm not gonna uh, give you a detailed logic for solving this problem, but rather I want to give you the big picture of this problem and what's the point and how come it gives you a feeling of difficulty when you try to solve this problem, especially to figure out the value of k here. First, let me give you some taste of graph of this function. Here, what we know is this function is 0 when x equals 0. Obviously, when you plug 0 into x here, 0 times e to the 4 times 0 square gives you 0. So this function goes through the point of origin here, and this is defined on a set of all real numbers, and this is a non-negative function. Let me see here this condition. And to figure out the shape of the graph of the function of f when the domain is negative, we need to check its derivative when x is negative. So take the derivative, and then by the chain rule, we first take the derivative of this one, and second we take the derivative of the second one and we add them together. So the first one will give you negative 4 times e to the 4 times x squared, and when you take the derivative to the second function, it will give you the derivative of this power 4x squared, which is 8 times x. So negative 4x times 8 times x, and e to the 4x squared is a common factor. When we arrange this term, it will give us negative 4 minus 32x squared times e to the 4 times x squared. And since this part is always negative and this part is always non-negative, it's actually positive in the domain of negative x, so the derivative takes a negative value for each negative domain. So the shape of graph in the negative domain, roughly it looks like it decreases and it passes through the origin. And we don't know whether the graph is tangent to the origin or not, but what we know is, since it's the negative function, eventually it will have some positive part for the domain of the negative x. But here we don't know the specific information for the between this part. We don't know yet. And this part we can figure it out. We have to figure it out with the relationship of this function of t. So let me give you rather specific picture for this relationship. Let me erase this part quickly here. Okay. For the positive t value here, y equals t, it's a parallel line with the x-axis. It has two solutions. One is negative solution. Here, the smaller one, it is designated g of t. It is always negative. And the other one is positive solution. Here, it is denoted as h of t. It's a positive. And their relationship between them is 2 times g of t plus h times h of t is always constant, let's say k. And first thing we can know is that when t goes to 0, uh, it maintaining a positive value. It goes to 0 from above. Let's see the graph. Uh, it will look like t goes to 0, and then the function of g of t, it goes to 0 because its limit value when x goes to 0 minus a. Let's say, let me give you a specific here, because it's continuous function when x goes to 0 from below, f of x is 0, and it is continuous. The g of t, when the t value goes to 0 from above, will be 0 here. And what's the limit value of h of t when t goes to 0 from above? In Korea, we legitimately say t goes to 0 plus. Let's take the limit in both sides here. Take a limit. T goes to 0 plus, and then we will have 0 plus, here will be 0, and then we're gonna have some limit value. It will become a k here. So the k could be 0 or it could be positive. It depends on the value of k. When the value of k is 0, the graph of y equals f of x will looks like it goes to the origin, and then it bounces up right away. However, when the k value is strictly positive, the graph will look like k is strictly positive, and then the graph will look like it goes to the origin and it maintains 0 at a certain point k, and then it bounces up to the positive value. So the k controls the distance from the origin and the first non-negative value here. We don't know the value of k yet, but the k controls the shape of the graph here. So that's the meaning of the k, and the shape of the graph is determined by the value of k. When we can figure out the specific value of k, and then we can specifically use this relationship between the inverse function g of t and h of t here. Okay, so next part, what is the value of k? Let me erase this part. Okay, here is what we have figured out till now. So the graph of f of x, it reaches to the origin in the negative domain, and then it could maintain zero value till the certain point, let's just say k, and then it bounces up. This is the rough graph of y equals f of x here. To figure out the specific value of k, we have to use this relationship, the integration, specific value of integration from 0 to 7 here. Since e to the fourth power minus 1 is positive, the ending point 7 should be larger than k, so that the area of this part will be e to the fourth power negative 1. The formula is integration from 0 to 7 f of x dx. To use the inverse function relationship here, let's say the value of f of 7 is t1, let's say this one, and then here we have a negative solution, g of t1, and then the 7 will be a positive solution, h of t1. So when t equals t1, this relationship will give us 2 times g of t1 plus h of t1 equals k. We don't know the value of k yet, but we do know the value of h of t1, which is 7. Okay, so here we can express the value of g of t1 as k minus 7 over 2 here. So this value is specifically expressed with respect to k here. To figure out the specific value of k, we are going to use the area of this part, let me say S2, and its counterpart will be located in the left side here. Its counterpart will be S sub 1 here. The relationship between S sub 1 and S sub 2 will give us a specific value of k. Luckily enough, we can express the specific value of area of this part here with respect to f of x, because we know its to ending point. Left ending point is k minus 7 over 2, right ending point is 0. And luckily enough, for the negative x, the function of f has a simple antiderivative. The antiderivative of negative 4 times x times e to the 4x squared is e to the 4x squared times negative 1/2. You can check this out by take derivative of this function here. I'm gonna do this one first here, but you can check this one by yourself. When you take the derivative of negative 2 times e to the 4x squared, it will give us e to the 4x squared. By the chain rule, we take the derivative of 4x squared, which is 8 times x. So the whole derivative will be 4x times e to the 4x squared. Anyhow, when you calculate this one, it will give us a value of e to the k minus 7 square minus 1, and it's half. It's k minus 7 each quantity square here, and this value enables us to use the relationship of inverse function with respect to the area. So the area S sub 1 is the area of the whole rectangle here. G of t1, its origin, its y value is t1. The whole area minus of this value, e to the, I'm sorry, in Korea we first write its denominator part, so this value. And then we have to be cautious that the value of g of t1 is negative, so the whole length of this width is negative g of t1, which is negative k minus 7 over 2 here. So when we calculate the area of S sub 1 will give us this value, e to the k minus 7 each quantity square minus 1 here. So this is our first clue. And to figure out the area of S sub 2, we're gonna use the same inverse function relationship with respect to its original function, its area here. The area of S sub 2 is in the same way is the area of the whole rectangle here minus the area of this part here. This part is from k to 7. The height is t1. And then since it's all positive, we know that 7 times t1 minus the area is e to the 4 power minus 1 here. Okay, so how do we connect the S sub 1 and S sub 2? Here is the counterpart. We're gonna use the equation of those function of t here. Let me erase this part first. Okay, to connect the two area S sub 1 and S sub 2, we express the area S sub 2 with a function of h of t. It's an integration respect to with respect to t from 0 to t1, right? It's an integration of these x values h of t, and then we move from 0 to up to t1 following the y-axis here. And then since h of t is equals to k minus 2 times g of t, we substitute this h of t with k minus 2 times g of t. And then we take integration here. This is our counterpart here. So if we take integration k minus 2 times g of t here, from with respect to t from 0 to t1, and then it will give us k times t1 minus 2 times integration from 0 to t1 g of t dt by linearity of the integration here. And what's the value of this integration from 0 to t1 function g of t dt here? This value is negative value of s sub 1, since g of t is always negative value and its integration value is negative, so it's a negative s sub 1. So here we have s sub 2, this integration value is s sub 2 here, is equals to k times t1. 2 minus will give us a plus 2 times s sub 2 here. And then we do know the values of s sub 2 here and s sub 1 here with respect to value of k. And then the last comment that I want to say about the k value, since k minus 7 over 2 is negative, here we have a quadratic equation. We have two k values, but we have to choose the k values which is less than 7. And then you will get k values as 5 here. 5 is the right choice. Don't choose the value 9 here. It does not satisfy this relationship here. So we figured out the specific value of k. You can compare those two equations. It's fun to figure out, or it looks like a puzzle. You can just puzzle this function of its power function. Actually, it should be 4. So you can solve this equation, right? And then we choose the k value which is less than 7. It is 5. So let me wrap up this problem. So we figured out the most important part, which is the value of k is 5, and we have the relationship 2 times g of t plus h of t equals to 5 here. And this value is 5 here. And then the small point here, let me give you a short comment here. To figure out the f of 9 here. So the 9 means value of x here. 9 is here. Okay. So nine is here. And let me say this value is f of 9 is t2. Let me say it's t2. And then it has a negative solution here. Here, g of t2. So from the relationship here, when t equals t2, 2 times g of t2 equals to 5 minus h of t2. And then we know from the inverse relationship here, h of t2 is 9. So the right hand side is negative 4, and it will give you g of t2 is negative 2 here. This part will be negative 2. So what does it mean? The value of f of 9, which is t2, is equals to its negative solution, which is negative 2, f of negative 2. And since we know the specific formula for the negative domain here, we can figure it out. Negative 4 times negative 2 times e to the 4 times negative 2 square here, which will be 8 times e to the 16th power here. You can repeat this process to figure out the value of f of a. You can do it yourself, and then you can get the value f of 9 over f of 8 here. So from this part, it's a long journey. It was a long journey, but we just saw how to approach this problem and what's the main point of it and what's the graph of the f of x here. Let me give you a last comment. How come it gives you a feeling of difficulty in the shoes of the high school student, the exam taker? As a high school student, you study with a textbook, and then the most graphs of the calculus book, high school textbook, gives you a graph of this like this one, and then usually it gives you specific formula. Maybe it has a separate domain. Let's say x is negative and x is not negative, but usually it gives you the specific formula for the separate domain. But in this part, it does not give you a specific formula for the other part of the domain. This is the first point. first difficulty point, and the second part, the uh, the zero part here, the extending zero part till the x value is k. This is an unusual graph. Unusual graph. I think you have never seen this kind of graph. Some graph, and then it has an extension of zero value, but it maintains continuity and it pops up again. It rebounds up. Almost, I think, few textbooks contains this kind of graph, or does not mention of uh, this kind of situation. So for the high school student who study with the base of the textbook, it's their main source of study to take this exam. It's very unusual. They've never seen this situation, so they have to use their imagination, extra imagination, to draw the graph of f to solve this problem. So this is why they feel extra difficulty on this problem. Thank you.